So the second structure or level of the protein structure is called the secondary level. This is where three-dimensional segments of the protein are formed, and it has two different structures. You have the alpha helix and pleated sheets. First, I will demonstrate the pleated sheets. They tend to look like a bunch of folded sheets, but you can also do them in arrows. They can be parallel or anti-parallel. And I'm not going to do a complete diagram of the molecules within, but I will do some of it. So you have your carbon on the outside, and you have also keep in mind that the primary structure of the amino acids is also the same as the structure within the secondary, so you will always have a carboxyl, a central carbon, hydrogen, amino acid, and an R group. So here's a carbon, and then you have your N, and you have your H down here, which has a hydrogen bond to oxygen. Again, I have not mentioned this before, but the bonds consisted within the secondary structure are hydrogen. And hydrogen bonds tend to be weak, but within packs they are a lot stronger in aqueous environments. So the secondary structure consists of only hydrogen bonds. And then you have C, double bonded to oxygen, which is on the outside. And then you have carbon to hydrogen, and here's your R group. And also something that is important about the secondary structure is the R group does not have much determination with saying what the amino acid will be. So as you can see, the R groups stay on the outside. It will say on the bottom or the top, but they don't form on the inside. And you have N and H. Again, I'm not doing a complete diagram, but you will be able to see what it kind of looks like. And then N, H over here. Oops, sorry. N, going to C, and H is down here. And then again, your other R group is over up top. So this is what a pleated sheet looks like. Pleated sheets tend to be a lot stronger than a helix. Within the pleated sheets, hydrogen bonds form between the carboxyl between the carboxyl and the amino acid group. Not between the R group and not between the hydrogen group. And again, they can face parallel or anti-parallel. And then we have a few amino acids that are involved in the secondary structure. I'll write this down. Okay. So you have an amino acid called tryptophan and trysin. Oh, my apologies. Triorsin. Okay. They're found only in the sheets, and they tend to have a larger R group, and it's dependent due to the size of the pleated sheets. They have more space than helix, allowing them to have more space within. Okay. And next, I will show you the helix formation.